Have you ever wondered why all life on Earth is carbon-based? And could there be other forms of life elsewhere in the universe? Back in 1869, when Mendeleev first created the periodic table that has tormented many students, it listed elements that form the foundation of everything we see today. Among these elements, hydrogen, carbon, nitrogen, and oxygen are the most fundamental. Of these, carbon dominates life on Earth. But why didn't life on Earth choose a different element? In the microscopic world, an atom's stability depends on the number of electrons in its outermost shell, which bond together through covalent bonds to form molecules. Carbon, with its 4 covalent bonds, can link together in a variety of three-dimensional structures, creating an immense diversity of carbon-based compounds. This makes carbon the most versatile element for forming complex molecules. Its unique properties of complexity and stability have provided the foundation for carbon-based life. Nature, using carbon as its building block, has created Earth's vast diversity of life forms. Additionally, carbon ranks 15th in abundance in Earth's crust, and in the universe, it's the 4th most abundant element after hydrogen, helium, and oxygen. This abundance is a key reason why carbon was chosen as the basis for life on Earth. But what about life beyond Earth? Could there be life forms based on other elements? As early as 1891, German astrophysicist Julius Scheiner raised an intriguing question: could silicon-based life exist elsewhere in the universe? This sparked an ongoing debate in both academia and science fiction circles about the possibility of silicon-based life. In 1893, British chemist Sir William Crookes supported the idea, pointing out that silicon shares similar chemical properties with carbon. Just as carbon can bond with 4 hydrogen atoms to form methane, silicon can form silane. Thus, it's conceivable that silicon could also form the basis of organic compounds in the universe. However, critics argue that silicon atoms have an additional electron shell compared to carbon, which weakens the control over its outer electrons. This makes silicon-based compounds far less stable. Furthermore, silicon is 1,000 times more abundant than carbon on Earth. If silicon-based life were possible, it would dominate the planet instead of carbon-based life. Carl Sagan warned that our focus on carbon-based life might limit our imagination in the search for extraterrestrial life. The universe is vast, far beyond our understanding, and somewhere out there might exist life forms beyond our wildest expectations, perhaps even silicon-based life forms. Astrophysicist Victor Stenger took this a step further, suggesting that the very idea of life being made of molecules might be flawed. In a universe with different properties, atomic nuclei or other structures could combine in ways we can't even imagine, potentially giving rise to life forms outside our comprehension. This means carbon-based life might not be the only form of life in the universe. If silicon-based life exists, how would it differ from us? First, in an oxygen-rich environment, carbon oxidizes to form carbon dioxide, a gas that is easily expelled by living organisms. But silicon, when oxidized, forms silicon dioxide, essentially glass or sand, posing a significant challenge for the respiratory systems of silicon-based organisms. Unless these organisms live on a planet hot enough to convert solid silicon dioxide into gas or liquid, breathing would be a major hurdle. Secondly, some silicon-based compounds are incredibly heat-resistant. Silicon-oxygen bonds can withstand temperatures up to 600,000 degrees, while silicon-aluminum bonds can endure nearly 900,000 degrees. For silicon-based organisms, temperatures around 400 degrees Celsius might feel comfortable. On a temperate planet like Earth, they would likely freeze to death. Finally, the appearance of silicon-based life would differ greatly from carbon-based life. Many researchers believe that if such life forms exist, they might look more like living, moving crystals than any familiar organic form. While we can speculate about the chemistry of non-carbon life forms, these ideas are still grounded in our understanding of carbon-based life. According to the Fermi paradox, the reason we haven't found extraterrestrial life may be because their forms are so different from our own. Without the means to recognize them, we're left with a universe that seems silent. If the dominant form of life in the universe isn't carbon-based but something entirely unknown to us, perhaps humans are the real outliers, unrecognizable and incomprehensible to other life forms in the cosmos.